Objective Geology, multiple choice questions with answers. This is the solved question paper of Pondicherry PhD Earth Sciences 2015 question paper, and I hope this solved question paper is useful for various competitive exams like CSR, NET, GATE, GSI and other exams. Welcome to set 4. Coming to the first question. A world-class wollastonite deposit occurs in southern part of Delhi Fold Belt at, the choices are A. Deri and Ambamata, B. Belka Pahar and Kera Tarla, C. Basantgarh and Pipla, D. Balda and Devaka Bera. So the correct option is world-class wollastonite deposit occurs in Belka Pahar and Kera Tarla. A world-class wollastonite deposit, it does occur in the southern part of the Delhi Fold Belt at Belka Pahar and Kera Tarla. These locations are known for significant wollastonite reserves, and Belka Pahar is particularly renowned as the largest wollastonite deposit in India. So B. Belka Pahar and Kera Tarla is the correct option. Next question. One of the following ore minerals is not common in beach placer deposits. The choices are A. Rutile, B. Hematite, C. Ilmenite, D. Magnetite. The correct option is hematite. So the common minerals which occur in beach placer deposits include heavy minerals like ilmenite, rutile, zircon, monazite and garnet. So these minerals are denser than quartz and other common beach sand components. They allow them to accumulate through the action of waves and currents. So the mineral which is not common in beach placer deposits is hematite. B is the correct option. Next question. A world-class barite deposit, it occurs in Kadapa Basin at, the choices are A. Vemula, B. Kodur, C. Vempalli and D. Mangampet. So the correct option is D. Mangampet. A world-class barite deposit, it occurs in Kadapa Basin at Mangampet. This deposit is considered as one of the largest barite deposits globally, and these are formed due to sedimentary exhalative deposits. That means these are formed due to sedimentary and volcanic action. Option is D. Mangampet. Next question. Typical profile of a laterite bauxite deposit consists of, so that is from top to bottom. So what is the profile of a laterite bauxite deposit? The choices are A. Bauxite, laterite, lithomarch, partially weathered bedrock bed. B. Lithomarch, laterite, bauxite, partially weathered bedrock bed and bedrock. C. Lithomarch, bauxite, laterite, partially weathered bedrock bed and bedrock. D. Laterite, bauxite, lithomarch, partially weathered bedrock and bedrock. So the correct option is D. Laterite, bauxite, lithomarch, partially weathered bedrock and bedrock. So a typical profile of a lateritic bauxite deposit from top to bottom, it consists of laterite, bauxite, lithomarch, partially weathered bedrock and bedrock. The sequence reflects the stages of rock weathering and the accumulation of aluminium rich materials. So D is the correct option. Next question. Uranium deposit types are correctly arranged in decreasing order of the age, that is old to young, in one of the following. A. Unconformity sandstone and quartz pebble conglomerate. B. Unconformity quartz pebble conglomerate and sandstone. C. Sandstone unconformity quartz pebble conglomerate. And D. Quartz pebble conglomerate unconformity and sandstone. So the correct option is A, that is unconformity sandstone quartz pebble conglomerate. The main types that include the unconformity related deposits, sandstone deposits, quartz pebble conglomerate deposits, vein deposits, and various others like intrusives, volcanics, and then metasomatic deposits. So the uranium deposit types are arranged in decreasing order, that is from old to young is unconformity, sandstone, and quartz pebble conglomerate. A is the correct option. Next question. Boiling of fluid, mixing of fluids, and fluid rock interaction are the important processes responsible for A. Leaching of metal from the source rock, B. Transport of metal by fluid phase, C. Dispersion of metal in rock, and D. Deposition of ore from a hydrothermal fluid. So the correct option is D. Deposition of ore from a hydrothermal fluid. Boiling of fluids, mixing of fluids, and fluid rock interaction. So these are all significant processes that can cause ore deposition from hydrothermal fluids, and these processes alter the chemical and physical conditions of the hydrothermal fluids, leading to the precipitation of dissolved metals and minerals. Next question. In ore processing, size reduction of ore by crushing and grinding results in A. Separation of gangue minerals. B. Concentration of ore minerals. C. Optimal libellation of ore minerals from gangue minerals. And D. All the above. So the correct option is all the above. In ore processing, reducing the size of ore through crushing and grinding primarily enables the mineral liberation, and it facilitates the subsequent concentration and separation processes. This process it prepares the ore for further steps like flotation or gravity separation by allowing valuable minerals which are to be distinguished from the surrounding waste rock. So in ore processing, size reduction of ore crushing and grinding results in all these processes like separation, concentration, and the liberation of ore minerals from gangue. So that's why D is the correct option. Next question. A basic assumption in the interpretation of fluid inclusions is that these are. So what is the basic assumption in the interpretation of fluid inclusions? So A, they are isobaric, and B, isochemical, they are isochoric, and D, isothermal. So the correct option is the basic assumption in the interpretation of fluid inclusion is that these are isochoric. A fundamental assumption in interpreting fluid inclusions is that they behave as isochoric systems. What does this mean? This means that the volume of the fluid within the inclusion, it remains constant after it is trapped in the host mineral. So the assumption is that the interpretation of fluid inclusions is that these are isochoric. C is the correct option. Next question. Degree of fill of a fluid inclusion, it refers to the relative proportion of A. Liquid phase to the total volume of fluid inclusion. B. Liquid and vapor phases to the total volume of fluid inclusion. C. Daughter crystal to the total volume of fluid inclusion. And D. Vapor phase to the total volume of fluid inclusion. So the correct option is degree of a fill of a fluid inclusion. It refers to the relative proportion of a liquid phase to the total volume of the fluid inclusion. So the degree of a fill of a fluid inclusion, it refers to the relative proportion of the liquid to the total volume within the inclusion. So it essentially describes how much of the inclusion is filled with the liquid when compared to its total space. So A, liquid phase to the total volume of the fluid inclusion is the degree of the fill of a fluid inclusion. Next question. One of the following metals, it does not form any mineral in which it is a constituent element. So the options are A, rhenium, B, platinum, C, niobium, and D, cerium. So the correct option is A, rhenium. Rhenium, it does not form in own minerals. It is primarily found as a trace element in other minerals like columbite, molybdenite, and tantalite. While rhenium, it can be a constituent element in some minerals. It does not typically form its own distinct mineral species. So that's why rhenium, it does not form any mineral in which it is a constituent element. Next question. Apart from lode gold deposits, gold is produced in India from A. Lead concentrate, B. Chromite, C. Copper concentrate, and D. Uranium ore. So the correct option is C. Copper concentrate. Apart from the lode gold deposits, gold is also produced in India from copper concentrate. Specifically, the Indian Bureau of Mines reports that Hindalco, a subsidiary of the Aditya Birla Group, it extracts gold as a byproduct from imported copper concentrate during the copper refining process. So apart from the gold lode deposits, gold is produced from copper concentrate. Hope you have followed the content and the questions. Hope you can share and subscribe, and hope you can give more suggestions. These are most welcome. So this can be useful for your exam preparation. So thank you so much, and see you in the next video.